Age over beauty.
Yeah. So, yeah, my name is Rich Cartwright, as Simon introduced me. I'm the managing director and also the founder of Heat Engineer Software. And I love taking an idea and putting it into a real life application, hence why I've created a software company, because trying to meet the needs of not only the homeowner, but also the heating engineer and the plumber as well. So that's essentially what I do and who I am.
And I'm Ethan Wadsworth. I'm the sales and marketing director of DiscreteHeat. DiscreteHeat are UK-based manufacturers of thermoskirt, which is a skirting board heating system used as an alternative to radiators and underfloor heating. And as Simon sort of kindly introduced, we are probably plumbing and heating's best kept secret, I would say.
I definitely concur on that, actually. Yeah, totally.
I mean, I was just saying, guys, just whilst we were setting up, that we've had lots of speakers on previously talk about, for instance, heat pumps, whether it be Graham Hendra, and then, we've been lucky to have Nathan Gambling and Joe Alsop on. And, when it comes to the adoption of heat pumps, there seems to be a messaging problem, they're between the consumers in terms of, you've got people, you've obviously got the likes of Daily Telegraph and everything saying that, you can't put heat pumps in every house, it's not suitable, blah, blah, blah. And what I would say, guys, on the call, if you check out Ethan's LinkedIn page, it was the first time, as a layman, that there was a description of how your heating system actually works, in terms of it's not there to heat you, it's there to offset the heat loss from the insulation that is not quite cutting the mustard. And it really, really just simplified it for me. And I completely got it. And I'm here in my basement and I'm looking at my newly installed skirting boards that don't act as radiators. And I'm thinking, bugger, why didn't I know about this before? So no, yeah, check out Ethan's page. But yeah, so Ethan, when we came up with this title, why emitters are key to achieving net zero, could you lead on to that, please?
Yeah, I think fundamentally there's a lot of people, as Richard and I, and probably yourself now, operate in the echo chamber of LinkedIn, where everybody is on the net zero hype. I mean, that's the industry that we live in. I think from the general public's perspective, though, I guess the nearest alignment I can make is that net zero is a bit like exercise, that everybody agrees it's a good idea, but not everybody can be bothered doing it. And that's really where I think our industry overlooks that. So our industry tends to be very like evangelical. It's either heat pumps work or they don't, or it's radiators are the best solution, or underfloor heating is the best solution. And what you get is this like heat pump evangelism, where you've got people on there saying that they are the perfect solution for every situation, and you've got the other end of the spectrum saying they're completely useless and they don't work. And the reality is that it's in the middle, probably more towards the end of they do work than the other end. And what we argue is that that's not where the majority of the resistance comes from. I think most pragmatic homeowners who are considering reducing their carbon emissions, I think most of them accept the fact that with the correct sizing and the correct installation, heat pumps are a fantastic opportunity for them. I think where it starts to crumble is the practicality of actually doing it. So it's not the theory, it's the practice that creates the friction. So when we say that heat emitters are key to net zero, the reason that we sort of pushed that is because one of the major impacts of reducing your overall flow temperature is that you have to increase the size of your emitters. Not always, because in a lot of cases, radiators are oversized anyway, as I'm sure Rich can attest to. But often, particularly in rooms like the room that I'm sat in here, which is sort of like an open plan kitchen dining room, they're the rooms that struggle at lower temperatures, and that's where products like us come in. I suppose the reason I've been invited on is because I'm also not really an evangelist. I mean, I don't have radiators in my house, so as a result, I'm not used to seeing them, which means I do hate them. Full disclosure, I do hate them, but I do accept the fact that they have a place. And with to achieve net zero, it's not or it's and it's heat pumps and reducing gas consumption. It's larger radiators and skirting board heating, because ultimately what the market needs to do is offer a range of solutions which basically overcomes that action threshold.
Yeah, essentially being really inclusive, isn't it? Being inclusive in what you could offer as a design is critical for providing that holistic approach, a holistic solution.
Yeah, exactly. I think that if you take your typical homeowner and say to them that, you want to reduce carbon emissions, you want to reduce energy consumption, they would all nod and agree that's a good thing to do. But everybody has a different action threshold. So if like us, you live and operate in this industry, it's very important to you to reduce your overall carbon emissions. There's certain factors like disposable income, whether you've got children or not, what sort of upbringing you've had. All of those things change how likely you are to take action. What we're aiming to do is lower that action threshold to make lower energy heating systems more accessible or more palatable to a wider range of people. So for me, the argument is less now about do heat pumps work or not, which is where it seems to have floated around for the last 5 years. I think it's more about how do we make this a practical thing to retrofit.
Yeah. It's the kind of the solution that you're offering is, I see it being far more acceptable within the wider community of people having to go through their kind of retrofit upgrades for their heat pump systems, or for that matter, any kind of like heating source. But obviously, our main agenda here is for renewables. Because there's so many, over the experience that I've had being in the renewable energy environments, is like, I think I'm in my 17th year now. One of the most the constraints that a homeowner has is that, I have to upgrade my radiators. I don't want a bigger radiator, and I don't want an extra radiator. But the solution that you're offering here, it's the thermoskirt. It's not only is it a neat, tidy solution that can actually meet the needs of the heat loss demand. So after completing a heat loss within a room, it's actually hidden as well. So it's like magic. It's essentially, you can't see it, and people won't be offended by it. And it's very discreet, isn't it? Essentially. So it's a really tidy, nice product. And just to let everyone know about this is that me and Ethan started chatting to each other a few sort of months ago, and to get their system into our software, because essentially it all starts with the design. It all starts with like the kind of the heat loss. Wouldn't you agree, Ethan? It's it has to. Absolutely, the starting point is essentially, what do we need?
Yeah, doing the design and doing the heat loss basically sets out the battlefield, if you want. That kind of arranges the parameters. It gives you it gives you the field that you're working within, and insulating is the first thing to focus on, and doing a correct design and improving the overall thermal fabric. And one of the things that I think really gets the message across to people is that not everybody, a lot of people work on the basis that your heating system heats you up, and it doesn't. Your heating system doesn't heat you up, because, as we've discussed, a warm room is 22 degrees, say, or 21 degrees. Personally, I would say it's 19. But that's a domestic battle which is about to commence any week now, actually. Now the heating system's coming back on, we can start arguing over the room temperature again. But ultimately, that goes to show that thermal comfort is kind of subjective. How warm do you feel?
Oh, totally.
That's because we're losing heat. Okay, so and for anybody who's watching who's sort of not in the know, your heating system doesn't heat you up. it offsets the heat losses that your building is failing to meet, or your insulation is failing to meet. So the more and more you insulate your property, the lower and lower and lower the heat demand is. If you had a 0-watt heat loss and a 0-watt ventilation loss, there would be no need for any heating system whatsoever. It'd be pointless, because it's 150 watts per person, plus your cooking, plus all of your appliances, plus whatever. There's heat inside the property. What's happening is it's getting out. So the thermoskirt is just a way of offsetting those heat losses that your insulation is failing to meet. And the poorer your insulation, the more skirting you need. And it's the same with radiators. The poorer your insulation, or the lower the flow temperature, the more radiant surface you need, or the more heating surface you need. We just disguise that heating surface as something that you would have anyway. I mean, it's behind me there. That skirting board over my shoulder is what's heating this room. And that's obviously spec'd to 55 degrees. So I think where it ties in with heat engineer is that heat engineer will arrange the chessboard, and then the engineer using it, or the consultant using the software, can then choose how they deliver that.
I think, just to sort of, to expand and add to that, Ethan. So regardless of any kind of like heat source, whether it's a ground source heat pump or an air source heat pump or others, and also regardless of any kind of emitter as well, you need to establish the base point of actually what is the heat requirement for this room, but also all the rooms as well. And so the software that we've created, it enables you to do the survey extremely fast, using a laser tool and the app, gathering that information, and also measuring the existing emitters as well. Because like I said before, if you're looking at like a typical kind of double panel radiator, it looks like, it's been fine with my gas boiler, not a problem. But actually, we need to do some calculations to work out whether that radiator is suitable if you go down the heat pump route. And it's, once you've actually collected those dimensions and the building materials for each of the rooms, you can work out the heat loss. The software will work out the heat loss for each of the rooms independently, but also it adds up all the total, so you can accurately design and specify the correct air source heat pump or ground source heat pump. Once you've selected the manufacturing model for the heat source and the flow temp, this is the bit where you can start changing and manipulate it. So we go with a flow temperature of 55 degrees, but as most of our audience might be aware, that the lower the flow temperature we have to our emitters, it's critical to try and get the best efficiency. So the lower we get that flow temperature, the more efficient the heat pump's going to be, and it's measured in SCOP, so seasonal coefficient of performance. So essentially, is efficiency. And we're looking at, say, a gas boiler might be a brand new gas boiler might be an efficiency of like, I don't know, say 92% or something. But a heat pump, we're looking at a minimum of like kind of 400%. So that's when I use the terminology seasonal coefficient performance, which is the industry measure of performance of heat pumps. Essentially, what that means is like the percentage of efficiency. So anywhere from like 400% to even a crazy high number of like 800% for ground source heat pumps that I've been hearing on the grapevine. It's absolutely crazy and really, really exciting. The next sort of phase, once you're like really, really happy with that particular heat source, whether it be an air source or ground source, is to identify what type of emitters are going to be really suitable for that property. And you come to our radiator. Just
on that, I mean, how many emitters are there then? Is it up till now just been radiators, and obviously now introducing thermoskirt and is infrared emitter, but it's infrared's not to the boiler, is it?
So to the homeowner, or someone who hasn't got a clue about heating, majority of the public are going to know what a radiator looks like, because everyone sees it right in the middle of the room. But as Ethan said, you've got underfloor heating, so you've got radiators, underfloor heating, you've got fan convectors, which are like radiators but have got little computer fans, little 12-volt fans hidden underneath, which are quite a clever sort of system. And then you've got mechanical ventilation heat recovery as well. That's kind of a whole different sort of system. But essentially, when we look at emitters as in like a single unit, radiators, fan convectors, and we've got underfloor heating. But of course, Ethan's got this amazing solution with a thermoskirt, which is not only is it accommodating for meeting the lower flow temperatures, but also it's very discreet. You can't, you walk into a room, so point where the heating's coming from, be like, is it underfloor heating? No. Oh, can't see any panels. Where is it? Where is it? It's an excellent solution. And one of the things when you're getting towards the end of our software as you're designing, so you selected the model, you know what the heat loss is then okay, how much space have I got to, in this case, put in a thermoskirt? So you're essentially measuring like the perimeter, aren't you? In meters, yeah. So the perimeter around the room, and then you know how much the thermoskirt you need. And within our software, you can not only change the flow temperature, trying to get that lower flow temperature to get more efficient, but also you can change the delta T. And when I mean delta T, I mean difference in temperature, because in a lot of cases, well, in all cases, sorry, well, not only were you concerned about the flow temperature coming out of the heat pump, we'll also want to make sure that the manufacturers are very happy with the return temperature of that water going through the system as well. And it's just about balancing. So yeah, and you can do that in our software. You can change it. We do all the calculations in the background, and essentially it spits out the results saying this is your heat loss, this is the heat pump you need, and this is the amount of length of thermoskirt you need for each room. And that report is downloaded, and it could be sent to any of the relevant parties that need to know about that particular project. So it's a very tidy system.
Yeah, the aim ultimately is to dissolve the mystery around it, right? Because we operate in this industry where like we sort of get it. That's because we talk about it every day. And if anybody's listening, do not talk about variable flow temperatures over dinner, because it will quite quickly lead to separation of friendships and marriages. But yeah, we can talk all day about variable flow temperatures and flow and return, ideal return temps and SCOPs and whatever. But the reality is that to most people that just flies straight over their head.
Yeah.
And to be honest with you, they don't really want to know all that. It's like explaining in detail how your car gets a better miles per gallon than the other. I don't really care how it does it, but does it do it? Is this car going to be cheaper to run? Is this car going to get me from A to B? Is it going to break down? That's what people want to know when they're considering renewable heating systems.
Graham Hendry's always said when he talks about sort of the adoption of heat pumps, like people know gas boilers have worked for them. They don't know how it works, but they've accepted it. And then it feels like the heat pump industry is just trying to do too much to talk about the technical side. And I get that, because obviously it's a new-ish product, and they need to prove themselves and people comfort. But ultimately, homeowners, they don't really go into. You have that manual, you get given it, and you put it on top of the boiler, and that's it. You never read it. You never read it again. They don't care. They just trust that it works. And heat pumps probably needs to be the same. So with your technology, there seems to be, it does what it does, and it's just getting wider acceptance. So are you partnering with heat pump companies? Obviously, it sort of sounds like it's in their interest to promote you.
Yeah, that's starting to happen, almost like a little bit of a waterfall in a way, that it starts to happen in a slow way, and then all of a sudden people really catch on. Because when it comes to emitters, and the reason why, to sort of bring it back to the main subject title, why emitters are key to net zero, is because ultimately your emitter strategy is the bit that you see, is the bit that you live with, it's the bit that's in your house. And people say to me, I suppose from our company size at the minute, so we've done about 70,000 thermoskirt systems in the UK. But the reason I say plumbing and heating is best kept secret is because we've done a lot, but not necessarily everybody knows about it. That's kind of the aim, I guess. But the what's happening is that people are reconsidering their heating strategy, and they think, I don't want radiators. What are my options? Now, without us, your options are underfloor heating. If you're on a standard wet heating system, either on a boiler or on a heat pump, and I don't think that the market fully realizes how big the opportunity is with people who don't want radiators but can't have underfloor heating. That's a massive window because I imagine if you stood on a high street and surveyed people, do you love your radiators? Most people would say no. It's not necessarily something that someone's going to, they're not going to die on that hill, are they?
No.
No, my radiators are amazing. I love them. Most people don't like them. They're in an inconvenient space. They don't look particularly attractive and so on and so on. Some people don't mind them, but that's kind of because they got used to them. We do quite a lot of export, and we export to countries that are introducing what they call hydronic heating systems. So take Australia, for example. They have, for years and years, have had blown air heating.
Yeah.
Same in North America. Now that they're moving over to heat pumps and hydronic heating systems, and there's companies now starting to market radiators there, and the market's really not accepting of them because they're like, why on earth would I put that on my wall? Why would I? Why the hell would I? That's disgusting. I'm not having that. And because we're used to them, we've seen them for decades and almost a century, or over a century. We are used to having radiators. Now, in reality, they're not particularly effective. They are good at delivering a high amount of wattage within a relatively small space. And part of our discussion really is around, it's not so much the wattage, but the distribution of that wattage that matters. So what we're finding now is, particularly in retrofits, is that you might use, say, heat engineer software to run a heat loss on a room, and it says this bedroom has a 500 watt heat loss, or say this room I'm in, which is a particularly good example because it's a weird shape, it's an L shape, and it's 8 meters long. So this room, let's say this room's got a 1.2 kilowatt heat loss. Well, at 45 degrees, you could put a double panel or a triple panel radiator over there, and you would get 1.2 kilowatts out of it. But it would be 1.2 kilowatts over there. And so how does it feel when you're over here, or how does it feel when you're at the other end of the room?
It's not an even spread of distribution. Yeah.
Correct. So underfloor heating solves that problem because it spreads that 1.2 kilowatts over every square meter of that space. And so do we. We spread that heat out across a greater area. So rather than having 1.2 kilowatts at one end, you've got 90 watts per meter on a heat pump, 90 watts, 90 watts, 90 watts, 90 watts, 90 watts, 90 watts, all spread around the room. So you get a much more even heat distribution. More even heat distribution leads to an increase in thermal comfort, which means that typically you can have your thermostat set lower. So the thermostats in my house are all set to about 19 degrees.
Yeah.
And when you ask most people how warm they like it, they'll say something mad like 23 or 24. If you set a thermostat in a house with underfloor heating at 24, you'll bake.
Yeah. Do you know what? It's really good you mentioned that, Ethan, because within our software, there's a default. So if someone said, "Oh, there's underfloor heating in the house, in the room," and typically it should be designed to 21 degrees. If it's underfloor heated being stated, we automatically reduce it by 1 degree. So we end up designing it to 20 degrees. So I wasn't aware of that regarding your system. So we've got to do it. So if anyone specifies the thermostat system in our software, we've got to make sure we change it. We reduce it by 1 degree extra, because these are essentially the guidelines from the Chartered Institute of Building Service Engineers. So these are the kind of British standards we're all kind of like following and stuff. So that's a really good, interesting point you made. So I'll be making a note of that for your system as well, Ethan.
Yeah, exactly. That's exactly it.
So in terms of sort of encouraging the adoption, because your products could lead to more, they're going to help ultimately with more heat pumps being installed. So again, there is that conversation with those manufacturers, but also from your side of the fence then, Rich and Ethan, I know you're constantly holding training courses, aren't you, for the installers to be comfortable with this. And it's not just all about radiators as a standard emitter. It's going to be getting the guys comfortable with installing you guys. So there's there's three parts to there's three audiences really, isn't there, for both of you guys, in terms of the general public, the installers, and then the manufacturers when it comes to getting them on side to promote you. And what's the risk there for the manufacturers, do they end up peeing off the radiator companies by doing that or not? Is there any risk to them? I can't see any risk.
No. I mean, so when you come to the point where you're specifying a particular heat pump manufacturer and their unit, it's important to look at their performance data and to see because the only way you could really upset them is that Ethan could say, oh, this particular client, we think we can get away with a 45-degree flow temperature. And as I said before, the lower the flow temperature, the more efficient the air source heat pump is. So if Ethan starts to sort of like say, if he was starting to dictate to say, no, we really want to try and aim for a 45 flow temp, but also the air source heat pump company might come back and say, well, actually, looking at the difference in temperature, the return temperature, we don't think the heat pump's going to perform. We would rather try and increase that flow temperature a little bit higher. They might come back for some certain reasons associated with hydronic balancing or something. But at the end of the day, that kind of conversation could be pretty efficient and pretty quick, and you can only determine that from having the results of the heat loss calculation, showing what the output of the thermostat will be at the different temperatures, and showing what the return temperature is going to be. And when that manufacturer's got information on the plate in front of them on their desk, they can literally, in most cases, they're going to accept it because the design's been done. If the maths has been done correctly, then the design's going to be accurate. And so in that so what I'm trying to say is that I can't see much resistance at all. In fact, I never see any resistance from manufacturers. They are more than happy to accept that the heating engineer is being very conscientious, has taken the time to design it and input the data, and as long as they're presenting that information, and there's something called MCS in the world of heat pump standards, when that handover pack goes over to the customer, then the customer, the homeowner, has confidence that that design is being carried out to the standards required. And so, yeah, regarding kind of selection of emitters and flow temperatures, you don't get any resistance from manufacturers because they provide certain information that you need, different outputs at different flow temperatures. We've got information, then we can be confident that whatever emitter we select, thermostat, it's going to be calculated accurately, and here's the evidence in this report. So that's my feeling on it. That's the evidence as well.
With manufacturers, okay, you know the term "follow the money." Well, money comes from sales, so anything that promotes sales of more heat pumps, they're on with. And I suppose the difference is that because we're the only manufacturer of skirting board heating, we don't have to align manufacturers with our brand. We don't have to say, we want you to promote thermostat. We only have to say we want you to, equally recognize skirting board heating.
Yeah.
Because at the moment, skirting board heating is us, and eventually one day we'll probably get copied. What we could do with is a really rubbish copy with a massive marketing budget. That'd be fantastic. But what happens with the manufacturers is that they are all fighting over a finite number of heat pump installs. Okay. And if anybody's went to the installer show earlier this year, it's like the heat pump show. Every other stand was like heat pump, another heat pump manufacturer, another heat pump manufacturer, and the whole market's in flux at the moment. Now, 50 to 100,000 heat pumps installed in 2023. Somehow they've got to get that up to 600,000 heat pump installs a year. That's a massive swing in uptake. Massive. And in order to do that, they need options. Now, you mentioned our training course. When you live and breathe a product like I have for sort of 15 years, you kind of become complacent to the market need for your product. You think, like, when you first invent it, you think, oh my God, everyone's going to love this. And then, when we brought it out in 2007, everyone just told us it was a load of rubbish. It didn't work. And now, in a way, like, the market's come to us because heating's back on the agenda. So, to go back 10 years, we'd go to like a national house builder and say, hey, we've got this product, you can get rid of your radiators. And they were sort of like, please go away. boilers and rads, we've got it sorted. Go
Mm.
away. It's cheap, it works, whatever. Now heating's back on the agenda and it's all back in flux again. The doors that were previously closed to me are open. Not only open, there's like a red carpet because they're going, oh my God, we really don't want to have to do underfloor heating on 10,000 houses a year. And we've got,
and we don't want these massive radiators in the houses as well, because it's all about, certainly the fuel crisis, it's all about reducing waste and boosting efficiency, isn't it? And it's essentially what your product could offer.
So exactly it. So we introduced this installer program, and we had about basically a guy in our team, Dave, and Dave, if you're watching, I love you to bits. Dave basically set up a training, marketing our training course and stuff like that. And I said to Dave, we need to start getting some heating engineers through our course, get them trained up on the product, get them out there, basically to provide the capacity to install. And within about a month, he came back to me and said, I've got 200 people on the waiting list. So I was like, well, we better go away and make a course then. So I sort of set him off on this like merry little journey, and he came back with loads of results, and I thought, oh God. So we set up this course, and we released some dates. Within 3 hours, it was fully booked. We released some more dates within a day. They were fully booked. I mean, we're booked up till the end of the year now. So we've got about 50 to 60 heating installers or heating companies a month being trained on the product. We've got another one coming up this Friday, and a huge proportion of them are heat pump installers. So if you take all of the plumbing and heating engineers in the UK, a very small proportion are MCS accredited or heat pump installers. The majority of them are still gas installers. But on our training course, it's about 80% are involved in heat pumps. And the reason is that they see a very immediate need for our product, because they watch orders disappear, or they watch customers get turned off by the idea of having to upgrade their emitters. And one of the things that we're doing with some of the energy companies, well, two in particular, I can't say who, but two of the energy companies, they have heat pump installation targets, set out by the government. You've got to install this many heat pumps, whatever. So some of them right now are making a loss on the heat pump installs, because they're trying to get it down to a price point where someone goes, oh, go on then. Well, what they're doing is they're leaving the existing radiators in place. Okay, so some of the radiators are fine because they're oversized already. Some of the radiators are undersized. So rather than take that radiator and upsize it, what they're doing is they're adding the thermoskirt on to bolster the heat outputs. So leaving the existing radiator in, tapping off the flow and return, and putting a few meters of the skirting in to give them the few hundred watts that they need. So, obviously I'm evangelical and say, radiators are a load of rubbish, but they have a place. I don't think the radiator companies are particularly worried, because you take like Stelrad Group and there are billions and billions of pounds worth of.
So when it comes to sort of say the energy house, and picking up on Rich's point that you've done the numbers, you've done the calculations, therefore it should, once the product or the system is installed, the house owner, the customer should be confident it's going to work. Is there an element of, what could the findings from Energy House 2.0, the recommendations, what are you expecting? Are they going to come out? Are they going to sanction your tech, or are they going to, what's the score? Is there a risk to putting your head above the parapet there, or are you just truly confident that this is the way forward and they're going to endorse it, if indeed, are you expecting them to endorse certain technologies? Because then it's just, presumably the uptake would be
so, well, to be fair to Salford University, they do already endorse our product in a way, because they know that it works. They can't publicly endorse a brand. They can't say, Thermoskirt is the best product ever, buy it, because they're an education and testing facility. But what the results from Energy House 2 will show is that you can achieve improved SCOT on the heat pump, and you can achieve increased thermal comfort without having to compromise internal finishes. You know, the internal aspect. And I don't think that the heating engineers or the nerds, if you want, the proper nerds, the ones that are on LinkedIn every day talking about really boring facts and figures, those guys, I don't think they fully appreciate how important aesthetics are to the average homeowner.
Yeah.
They think, well, this is better. Bigger radiators are better. We could put a radiator here and a radiator here and a radiator here and a radiator here, and then you'll be able to run your heat pump at 30. Well, great, but I don't want that. So then you've got this argument between practicality and performance.
Yeah.
And we argue that our product gives you the best performance in the most practical package.
Yeah.
And that's what the test data from Salford University will prove. Ultimately, what Barratt's and Bellway are doing in there, the reason it's so interesting is because Bellway have a house that's on a heat pump with radiators, and Barratt's have a house that's on a heat pump with thermoskirt. So there's a direct comparison there in a controlled environment that's going to tell you exactly how long the heating system has to run for, what the cool down times are, what the thermal comfort levels are. So they have bulb sensors hanging all around all of the rooms, which monitor thermal performance. But it's pretty much the exact same test that BizRia did on our product back in 2007. You know, heat distribution. If you want, I can show you an example.
Yeah, go on.
That looks like. You have a quick look here. I'll just share my screen with you guys.
Just while you're doing that, Ethan, Rich, does your software work alongside infrared then? Because when Ethan was talking about and you know, it's skirting board heating, radiators, and underfloor heating. I mean, it's just
So one of the advantages if your heating engineer is taking on is using thermal imaging, when you're conducting a survey in a house, gathering the dimensions of a room to work, you know, because you need to know that the size of the windows, the floor area, etc. That's quite straightforward because you can use a laser tool. Please don't use a tape measure. Let's move forward, shall we? You know, a laser tool is your best friend on a survey, using the plus button and the area button, laser tool. So once you've got the dimensions, that's fine. It's easy. But one of the challenging points is that what's in that wall there? Oh, it's a cavity. It's a cavity, is it? Have you got insulation in there? Well, I think there's insulation in there. Yeah, I'm pretty sure. Well, okay, then there could be some witness marks on the outside of the wall, which you could look at. So where in the past the installation companies drilled holes in and injected in insulation. But there's been quite a few instances. Quite a few of our users give us this feedback. They say walk around with a thermal imaging camera that they've taken a photograph from outside or inside. Doesn't really matter. You can still see the thermal imaging distribution. It's like, over there, it's slightly warmer, and over there, it's colder. And it's because in these instances, the insulation is sagged down. So in fact, actually, it gives a really good indication that how efficient the insulation is. And if you're in the attic as well, if you've got like a room in a loft space, it's being converted. Again, going with that thermal imaging camera, will pick out cold and hot spots. And in certain cases, I wish I had one years ago, because I remember having a client that I did a heat loss, and they said it was quite cold in this particular area of this room in the loft space. And I only found it from calling into the spaces and finding that there was a big cold spot, and it's because the builders never put insulation in there. There was no insulation. I was like, there's your problem. Put that in there, and then your underfloor heating would be absolutely magic, and the room will heat up. And that was the solution. But you know, if I had if I had a thermal imaging camera, I would have had to be crawling through the space, the small confined spaces in a loft. I'm going to be taking a picture, and this is, having this particular technology is brilliant on hand. Highly recommend it.
Cool.
I think this image, I don't know if you can see that, I am screen sharing, and presumably you can see what I'm looking at. This example here is your classic suburban house, if you want. It's a 4-bed detached house, but some of it was built in the 1970s. The original main house was built in the 70s. Then it was extended on the ground floor in the 1990s. So it had polystyrene cavity wall insulation put in. And then in 2018, it was extended above for the first floor, which has got, modern, Kingspan, Celotex, PIR insulation in. So you've got this mishmash of heat outputs, heat requirements. The 70s part is going to lose heat a lot faster than the 2018 built part. And that's why it actually becomes a lot more of a challenge for someone to say, this is how much heat you need, because it's going to be different in that room to the other. Your watts per square meter are going to be different in one room to another. And this example kind of explains what Rich is talking about. It's minus, I think the outside temperature is about -10. If you look on the patio here, or the snowman, the snowman's like -12, -11. This is up in the Peak District. But the house itself is -6, and that's because the house is losing a lot of heat. There's a lot of glass there, so it's about 5 degrees warmer, the house, and the environment around it.
This is the external surface temperature of that building material, though, isn't it?
Yes, and when you go inside the house, that's when you look
go.
at the even heat distribution. Okay.
Yes. Look at that.
So the purpose of the skirting, which you can sort of see down on the left-hand side. So firstly, just to prove the point, human beings are the warmest thing in the room, even if you have just come in from it being -11 outside. You are about between 32 and 36 degrees, depending on where you measure. So you're losing heat to the room. The room itself has to create a comfortable environment, i.e., an environment in which you lose heat at a rate that's acceptable to your brain. Basically, if you lose heat too quickly, you feel cold. If you lose heat too slowly, you feel stuffy. But as you can see from the actual room temperature, that it's about a 1 degree differential from the wall to the ceiling to the dining table in the middle of the room. Even the glazing internally is like 16 degrees. Now, that's because the room is being heated evenly with radiant heat. So you don't get this sudden drop off in temperature when the heating system turns off. So can you see there that it's like 21 degrees on that side of the room, 20.6, and it's like 19.9 on the external wall. But the table, the floor, the ceiling, the windows is all of an even temperature. This video here, it shows how the skirting's plumbed in. So the flow and returns actually, this is a retrofit. So the flow and returns drop down inside this cupboard here, and they go to like a little distribution manifold. So even though the whole ground floor is operated as a sort of one zone, the distribution manifold feeds out to I think there's three separate thermoskirt systems. And you can see that the flow and return temperatures are, about 45, 35, something like that. So this is on a boiler, but turned right down. The pipework goes under the floor. You can sort of see the orangey lines on the floor, which is showing that the pipework's been chased into the screed. There's what we call a heated threshold, and that runs across the patio doors. So patio doors and
I was wondering what that was.
Glazed areas. Yeah. So glazed areas are the area of highest heat loss. So particularly bifolding doors and sliding doors. So by us heating below them, what that does is it continues that thermal envelope around the room and offsets the heat losses where the glazing is.
Have you taken a thermostat and just put it in a horizontal profile? Is that what you've done with that?
Yeah.
Okay, cool.
And then it's fitted here as a kitchen plinth.
Nice.
So if you look at that, we've actually put the heating onto the kitchen plinths. So it has like a foil backing behind it to reflect all the heat forward.
So you don't heat your cans of baked beans.
Yeah, pre-warmed for extra efficiency. But yeah, you can see on the flow and return. So you see that the bottom pipe is slightly warmer than the top two.
Yeah.
And that's really how the product works. So even when it's -10 outside, you can create a very comfortable environment at a low temperature because of the way that it's heated. And this is a typical sort of heating cycle. So you can see that the outside temperature here is 0 degrees in the middle of the day. So if you look at the top line up here, you got, it's 11 a.m. The actual temperature in the room is 19.3. The set temperature is 19. Outside is 0. Because the thermoskirt, unlike radiators, heats everything up in the room, it's radiant heat, it's not convection. With radiators, because they're convection, in leaky houses, when the heating system turns off, that air changes and the temperature drops down very quickly.
Yeah.
So with radiators, what you tend to find is this on off, on off, on off, on off cycling right the way through the day. More like underfloor heating, thermoskirt will bring the room up to temperature, so you can see that there's about 2 hours in the morning. And then because it's radiant heat and everything in the room's warm, it will maintain a relative temperature throughout the day, sort of around 19. And then in the evening, it jumps up to 20, 21 for a couple of hours. So if you look on the top there, the hours run is 4 hours and 10 minutes. So on a winter's day, you're running your heating system for 4 hours.
Yeah.
Whereas
Not
radiators seem
on,
to
off,
be
on, off.
on. Yeah. Interesting.
Which is
So
a really, yeah, it's because you definitely want to avoid that on off, because a lot of our listeners might not be kind of aware of that. But if you have a heat pump that comes, the more times a heat pump comes on and turns itself off and comes back on again during the day, is an indication that it hasn't been designed correctly. So it's you definitely want to reduce that. It's called cycling. So you want to reduce that cycling. And you can only do that by carrying out a good, accurate design. So
yeah, that's what the threshold heater looks like there. So if you can you see that picture?
Oh yeah, the black line,
yeah,
black section.
Yeah, so that's the heated threshold.
Brilliant.
So what we do is we color match it to the doors.
Nice.
Whether it's grey or normally, I mean, we say color match it to the doors. You can pretty much guarantee it's going to be white, anthracite, grey, or black.
Yeah,
that's like 90% of doors. But yeah, and it sits within the floor profile, so it looks like part of the door detail.
Yeah, that's
and this is why I mainly focus around how the heat is delivered and not the wattage. And it's so frustrating to me when we get sent a list of radiator outputs and they say, "Can you match that?"
Who's sending you that list though? Who's saying, "Can you match that?" Not the homeowner.
Normally like a lazy QS at a construction company. He knows what he's paying for his radiators, and he goes, "Can you match these outputs?"
Yeah. Okay.
We say we don't ask for a radiator schedule, we ask for a heat loss. If you can give us a heat loss, we'll tell you the best way of delivering that heat. So part of my sort of package of recommendations is to push forward heat engineer to say, look, this is something that consultants and architects can access.
Yeah.
That doesn't require a degree in thermodynamics to operate. You input some pretty simple to collect information, and it spits out exactly what it is that you need. I don't know whether Rich, if you wanted to discuss the drop down option and how you select your emitters from the drop down.
Yeah, no, sure, definitely. So once you've completed the survey, you've sent the survey to our system, and speaking like trying to be a bit more inclusive, like any heat loss software, long as you've got the results and you know the results of not only the total to size the actual heat pump, but also the heat loss results for each and every individual room, that's when you can take that figure. So let's just say 500 watts. So we've got a living room at 500 watts, and that's what any heat loss software would say. You're at the point where you need to select, the thermoskirt, and within our system, what it allows the user to do, whether that is an engineering, a surveyor, or heating engineer, what it allows the user to do is has the name in the room, has the heat loss next to the room, and from the drop down, you can select the thermoskirt, because you've got two models, haven't you, Ethan? You've got two models. You can select one of the two models. You can state the length, how much length you've got available in that particular room, and it will tell you what the output of that thermoskirt is against the heat loss of the room. Now, there are two more inputs which are at the top of this particular page, which we have already been put in. That's what kind of flow temperature you want. What's the maximum flow temperature you want to the thermoskirt? And also what difference in temperature do you want, which essentially works out what the return temperature is going to be. So as long as we know what the flow temperature is to your thermoskirt and what the return temperature is going to be, we can then tell the user of the software what the output is going to be of the thermoskirt based upon the length of the thermoskirt has been selected for that given room. So it's a job that's done in seconds. Honestly, it's done in seconds. You go to the emitters page, you click on which model you want, you type in how many meters. I want 5.2 meters, whatever, and then it says, it turns green, in fact, actually. So if the output is acceptable to the requirement for that room, it turns green. And I will be making like a YouTube video of that. Certainly I've got it planned for this afternoon, actually, so I'll be doing that. So that'll be on YouTube, just to show how to use the thermostat system within our software. But
one of the things as well, Rich, is obviously I don't want to we don't want to come across as if we're just plugging my product, although it is the best emitter option, of course. Is that you can actually put in the radiator that you've currently got, right?
Yes,
and then you can reverse engineer how much skirting you would need in addition.
Oh yeah, I think that's really important to mention. So when you do come to our kind of radiator page, we need to change the term, because it used to be called, in fact, it still is called new radiator page. So you have to excuse Ethan. So we will actually be changing it in our version 2 of our software, which is being released in October. It'll be just literally emitters. But you're quite right. So if they got a current, say, a K2 radiator. So those who don't know what radiator size is, a K2 is like pretty much a double panel radiator. Call it 1 meter wide by 500 mil high. If that's existing in the room, and with the new lower flow temperature, because they used to have a gas boiler, the new lower flow temperature, they want a new lower flow temperature of the air source heat pump. If they're like, oh, do you know what, that radiator needs changing, need to take it out, or it needs to be bigger. Like, actually, no, let's leave that in there, and under that line you can say, let's add some thermostat. So actually, this is the hybrid sort of like solution that Ethan was mentioning earlier on, that you can leave the existing radiator in there and add an extra little bit of length of thermostat, and you've got a perfect solution for that particular room. And our system indicates that, because you can have multiple kind of emitters in there, and so that's where thermostat is becoming a bit of a hybrid solution as well. So yeah, it's pretty easy to do as well. Set up in the software.
Thanks for that, Rich. Yeah, we're just coming up to the end of our hour now, and that's sort of perfectly timed. What I would say is, whilst, Ethan, we have been talking about thermostat a lot, it is actually like, well, I used a bad analogy yesterday when I said, you want to be the Hoover of skirting board heating, but obviously you don't want to be the Hoover of skirting board heating. But that's with my old.
I do.
Yeah, but we have been talking about thermostat a lot, and obviously in tandem with Heat Engineer. But what we're trying to do for the guys on the call is that this is new technology. This is offering an alternative to radiators. Which when I think the one thing that stuck out from the conversation that you said, Ethan, was how in the States, because their heating systems previously haven't required radiators. Could you imagine being a radiator salesman in the States? Like now, it's like, why would I have this dirty grey steel box on? I mean, it's just ridiculous. It's just mental. So we are used to it. And whilst this wasn't a product push, it's taken on the previous conversations we've had with all of the other technologies, whether it be infrared or the stuff that's been highlighted by William in Energy House and Oliver, etc. It's just sharing the knowledge, really, and sharing and opening up people's minds. We tend to have a lot of architects.
Changing someone's mindsets, isn't it, on the different solutions?
Making them aware that there is an alternative to radiators, and actually when it comes to reducing carbon and in reducing flow rates, then this is an option, and it's giving you a voice, and hopefully that's helpful to you. And thanks for your time, both of you, for coming on the call and explaining how emitters are key to achieving net zero, because I wouldn't mind being.
You could reframe that, Simon, that it's choice is the key to net zero. Really.
It's exactly
having choice.
Because
I think that the moment somebody is hemmed into one particular, this is the way you have to do it. The whole thing kind of becomes a bit awkward and a bit difficult. Particularly when you're trying to strike that line between architects and consultants. The consultants need to make sure it works, but the architect needs to make sure it's practical, usable, aesthetically appealing.
No, you nailed it. Cool. All right then. Thank you very much.
Brilliant. Thanks so much. Thank you
Appreciate
again,
that.
Simon.
No, and thanks for people on the call. And like I say, guys, I'll share the video with you. It'll be uploaded, and yeah, I'll get it edited for tomorrow.
Brilliant. Thanks, everyone. Thanks for
Cheers. Have a
listening.
good
Thank
afternoon.
you. Cheers.
guys.
Thanks,
See ya.
guys.
Bye.
Bye. Bye.